Lesson 5.4, Solve Systems by Elimination. You can eliminate a variable by adding equations with opposite coefficients. So we're going to solve this first problem by elimination. Notice the y terms have opposite coefficients. So we are ready to add. So we'll add them together. Notice that y plus negative y will eliminate. We get 6x equal 12. And now we just have a tiny little one-step equation that we're going to solve by dividing both sides by 6. We find that x is equal to 2. Now we're going to choose one of those original equations to solve for y. I chose the first equation and I've plugged in 2 for x. And now we just simplify and solve for y. We find that y is 4. So the solution to this system is 2, 4. Sometimes you need to change one or both equations to get opposite coefficients. You can multiply an entire equation by a number to get an equivalent equation. Example 2, solve by elimination, problem A. We could eliminate x by multiplying the bottom equation by 2. So I'm going to take that bottom equation, I'm going to multiply it by 2, and keep the first equation the same. For the bottom equation, when we multiply by 2, we get 14x minus 16y equals 0. Then add. We get a simple one-step equation. We'll divide both sides by negative 14 to solve for y and find that y is equal to 0. Choose either original equation to solve for x. I'm going to use the second equation, 7x minus 8y equals 0. We plug in 0 for y. 8 times 0 is 0, so 7x minus 0 is just 7x, and that's equal to 0. Divide both sides by 7, and we get that x is 0. So the solution to this system is 0, 0. For our last problem, notice that we do not have an x that's a multiple of the other, or a y that's a multiple of the other, so we're going to have to eliminate y by multiplying the top equation by 3 and multiplying the bottom equation by 2. So in this case, we're going to change both equations. So I multiplied the top equation by 3. I've multiplied the bottom equation by 2. These look like distributive property where we're multiplying each term by the multiple. Now we add the equations. 27x plus negative 10x is 17x. 12y plus negative 12y are opposites that equal to 0. And negative 81 plus 30 is negative 51. Divide both sides by 17 to get x by itself. And we get that x is equal to negative 3. Solve for y. I'm choosing the top equation. You could choose either original equation and plug in what we know for x, which is negative 3, and we'll solve for y. So simplifying, we get negative 27 plus 4y equal negative 27. We want our y term by itself. We've now just got a little two-step equation to solve. So I'll get rid of this negative 27 by adding 27 to both sides of this equation. It actually cancels on both sides, and we get 4y is equal to 0. Then divide both sides by 4, and y is equal to 0. So the solution to the system is where x is -3, y is 0. We've solved the system.